Greetings to all viewers. This is Professor Ankit Singh. We'll now start the numericals on module 2, that is geometric design. Okay, we'll firstly consider the numerical on camber. In a district where rainfall is heavy, two types of road pavements are to be constructed. Okay, and the data is as follows. First one, two-lane state highway with bituminous concrete surface. And the second one is major district road of WBM pavement or waterbound macadam pavement, and this is 3.8 meter wide. What should be the height of the crown with respect to the edges in these two cases, assuming the straight line camber? Okay, so in both the cases we need to assume that the camber is straight line camber, and we need to find out the height of the crown. Okay, so for the first case, for state highway, the width of two-lane pavement is 7 meters. This is the standard value. And for bituminous concrete surfacing in heavy rainfall area, we provide a camber of 1 in 150. Okay, this is also as per standards. We had already discussed these standards during our theory classes on this topic. Now, we need to find out the rise of the crown. So rise of crown with respect to the edges is equal to 7 by 2, that is half the width. Since the crown is nothing but the highest point on the road and it is at the center of the road, center of the width of the road. Okay, so this slope will be on both the sides of the road. So in order to find out the height, you consider half of the total road width. So since the total road width is 7 meters, we take 7 by 2 into 1 in 50. So 1 in 50 is 1 by 50. So you get 0.07 meters. Now considering the second case. For WBM road in heavy rainfall area, we need to provide a cross slope of 1 in 33. Okay, this is standard. And the width given is nothing but 3.8 meters. So using the same formula, 3.8 divided by 2 into the cross slope that we need to provide. So 3.8 by 2 into 1 by 33 is nothing but 0.58 meters. Now the second type of numerical is numericals on side distance. Firstly, we'll start with stopping side distance. The question is as follows. Calculate the safe stopping side distance on a level road stretch for design speed of 50 km/h. For there are two conditions. Okay, first one, A, two-way traffic on a two-lane road, and B, two-way traffic on a single lane road. Assume coefficient of friction as 0.37 and reaction time of driver as 2.5 seconds. Okay, so we need to find out the safe stopping side distance for both these conditions. So in this solution, given velocity is 50 km/h, reaction time small t 2.5 seconds, coefficient of friction 0.37. Okay, so we know that SSD or safe or stopping side distance is given by 2.278 into V into T plus V squared by 254 F. Now this formula is used when V is given in kmph. Substituting the values, in place of V you substitute 50 and in place of T you substitute 2.5. Solving this we get 61.4 meters. Okay, so this is the SSD. Now we have two conditions. Okay, SSD when two-way traffic on two-lane road. In the case of two-way traffic on two-lane road, the SSD would be different for each of the lanes, and hence it would be directly equal to our found out value. Now in the second case, the SSD when single lane road with two-way traffic. Now since two-way traffic exists in the same lane, okay, so we need to provide SSD for both the directions for the same lane. So it will be 2 into SSD. So 2 into 61.4 should give us 122.8 meters. Moving to the next problem. Calculate the minimum side distance required to avoid a head-on collision of two cars approaching from the opposite directions at 90 and 60 kmph respectively. Assume t is equal to 2.5 seconds, f is equal to 0.7 and braking efficiency of 50% in both the cases. Okay. Now let us have a look at the solution. Given is velocities of two different cars. The first one is 90 kmph, the second one is 60 kmph. Reaction time is 2.5 seconds. Now, since the braking efficiency is given here, the coefficient of friction is dependent on the braking efficiency. Therefore, effective coefficient of friction is nothing but 0.7 into 50%. Okay, so 50% can be written as 50 by 100. We get 0.135. This value we will use in the formula. Now SSD for car 1. The formula is 0.278 V1 into T plus V1 square divided by 254 F. Substituting the values of V1, T and F, we get the value 153.6 meters. This is for car 1. Similarly for car 2, use the same formula, substituting value of V2 over here. Okay, V2 is 60 kmph. We get the value 82.2 meters. Now we need the total SSD in order to avoid a head-on collision. So it would be the sum of SSD1 plus SSD2. So 153.6 plus 82.2, it will give us the value 235.8 meters. Moving to the next problem. Calculate the stopping side distance on a highway at a descending gradient of 2% for a design speed of 80 kmph. Assume other data as per IRC recommendations. Okay. So what is the data that is given? In the solution we write it down first. So velocity is 80 kmph. Gradient, which is downward, hence it is designated by a negative sign, is 2%, so it can be written as minus 0.02. Reaction time, the standard value is 2.5 seconds, so we consider this. And also coefficient of friction is 0.35 for 80 kmph. Okay, so this is also as per given standards by IRC. Okay, so the formula that we use for gradient, when gradient is given for SSD, is 0.278 Vt plus V square divided by 254 into F plus or minus N. Now this is positive for positive gradient and negative for negative gradient. Okay, or upward it will be positive and downward it would be negative. Substituting the values, V equal to 80 kmph, T 2.5 seconds and F is equal to 0.35 and N is minus 0.02. We get the value of SSD as 131.7 meters. Moving to the next problem. The design speed of a road is 65 kmph. The friction coefficient is 0.36 and reaction time is 2.5 seconds. We need to calculate headlight side distance and the intermediate side distance. Okay. So as we all know already, as discussed in the theory classes, headlight side distance is equal to the stopping side distance and intermediate side distance is twice of stopping side distance. Okay. So what we do is, firstly we need to find out SSD. So what is given in the question? V equal to 65 kmph, T is 2.5 seconds and F is 0.36. So HSD or headlight side distance is equal to SSD and the formula is as follows: 0.278 Vt plus V square by 254 F. Substituting the values, 65 in place of V, 2.5 in place of T and 0.36 in place of F. When solving we get HSD as 91.4 meters. Now this is the SSD value, okay, which is equal to HSD. And we know that IHD, or the intermediate side distance, is equal to 2 times of SHD. So 2 times of 91.4, IHD is 182.8, okay, in meters. So we'll solve the next problems in my next class. Thank you.